Okay, so solving inequalities that involve rational functions. Well, first it starts out just like just regular inequalities. It's where your x-intercepts are, but because it's a rational function, it's also going to be where my vertical asymptotes are located, or my breaks and my intervals. So we're going to have to find our x-intercepts, which remember, well, first thing is it has to have 0 on one side, and this one does. So my x-intercepts, the shortcut is it's going to be where my numerator is equal to 0. So it's going to be where x minus 3 equals 0, which is at positive 3. And then we said it's also going to be our vertical asymptotes, where our vertical asymptotes are going to be where our denominator, oops, I meant to write it out in words, our denominator is equal to 0. So it just happens to be where the top and the bottom of the fraction are both equal to 0. So even if they are written as like two different fractions being added or something like that, you need to go ahead and combine them to be able to do it. Alright, so there's my two key points that I need. Now, something to be careful though is remember vertical asymptotes will never equal 0. So if you have a vertical asymptote, you're always going to use a parenthesis at that number. Now an x-intercept, like we saw at the beginning here, it could. So go back to your inequality and notice it does not. So we know at the positive 3, it's also going to have a parenthesis. I usually try to remember to go ahead and check these before I set up my table because I'm there and it's easier for me to glance up and see parenthesis or not, or see bracket, than it is for me to remember, oh yeah, this one was an x-intercept, so I need to go check, and this one was not, so it's a vertical asymptote, so therefore it's always going to be a parenthesis. It's just easier for me to go ahead and do it there. But as long as you do it before you finish your table, whatever works for you. Alright, so my table, same table, interval, pick an x value in that interval, solve for the y value, and tell me the sign of that y value. So my interval will always start at negative infinity, and it's going to go to the smallest of these numbers. So I have 3 and negative 5. So negative 5, and it says it's a parenthesis. So then we go from negative 5 to 3, which is also a parenthesis. And 3, I don't have any other numbers, so it's going to go to positive infinity. So we need to pick a number in each interval. I'm going to change colors. I don't like it being just all black. I meant to change before I did the intervals, but it is what it is. And then I'm going to plug this in. So when x is negative 6, I have negative 6 minus 3 over negative 6 plus 5. So negative 9 over negative 1, which is a positive 9. Plug in 0. It's negative 3 over 5. Excuse me, so negative 3/5. And then plug in when x is 4. So positive 1/9. And then look back at your inequality. You're looking for when it is less than 0. Less than 0 is negatives. So right here's our solution. So our solution is from negative 5 to positive 3. Both of them have parentheses. Okay, moving on. Let's look at number 6. So let me scoot that up here. So number 6 already has 0 on one side. So remember, it's going to be our x-intercepts, which is where the numerator is equal to 0. So x plus 2, x minus 4 equals 0. Solve them both, so at negative 2 and at positive 4. And my vertical asymptotes, which is where the denominator is equal to 0, so x times x plus 5. And so set them each equal to 0 and solve, so x is 0 and x is negative 5. Vertical asymptotes will always be parentheses, but what about these x-intercepts? Check out that inequality. It has an equal to, so we're going to use a bracket at the negative 2 and the 4. Alright, so let's set up our table. I'm actually going to make my table over on the right side because I need a little more room. I'm not going to use that number line anyways. So it's just kind of hanging out there. So we have interval, x value, y value, and the sign. So remember, it starts with negative infinity. And it goes to the smallest of these four numbers that it gave me, which is -5. And I see it has a parenthesis. And then from -5, my next smallest one is -2, which has a bracket. And so from that -2, the next smallest is 0, which is a parenthesis. From the 0, we go to 4, which has a bracket, and there is no other, so from 4, we have to go to positive infinity. Alright, so I'm going to have to extend. I'm going to have to do a little more work. Oh, yay. Alright, so pick x values in those intervals. And we're going to plug them in and solve for the y value. So, when x is -6, we got -6 plus 2 times -6 minus 4 over -6 times -6 plus 5. And so I get 40 over 6. I don't even have to reduce it, guys, because remember, the big thing I needed from that is that it's positive. Okay? And then we're going to plug in -3. And I got -7/6. We're going to plug in -1. I think I'm going to run out of room there. I'll just have to do it below a little bit here. So +5/4. Plug in +1. Don't even worry about reducing it. Remember, the big thing is we need to know if it's positive or negative. And finally, what I've been waiting for, the last one, so plug in 5. +7/50. Alright, so going back to our inequality, because I need to know, do I need positive or negatives? I'm looking for where it is greater than 0. What kind of numbers are greater than 0? Positive numbers. So, we have a positive here, and there. So I have 3 solutions on this one. So this one's solution is from -infinity to -5. And then -2 included to 0, and 4 included to infinity. And so there is my solution for this problem. Okay, so on number 7, I'm just going to look at it to help you get started here. One thing is it does not have 0 on one side, so we're going to have to move that 2 over. which means we're going to have x over x plus 2 minus 2 greater than or equal to 0. But remember I said you want to have one fraction. So that means we're going to have to subtract these. And how do you subtract fractions? Common denominator. So we want to find our least common denominator. So if I could factor my denominators out, I would need to, but they're not. So if nothing else, a common denominator, so I just multiply them together. But the least common one here is actually x plus 2. And so to show you how I got that though, so my least common denominator, once I factor out my denominators, has to include everything that's in the denominators. But if some things are repeated between the different fractions, I only have to write it down once, or the maximum number of times that it's in one fraction. So when I start out, I don't have anything written down there beside where it says LCD equals. There's nothing. So I'm going to have to put an x plus 2 there. And since it's together with a plus sign, put it in parentheses. And then I check the other ones. So when I look at the second fraction there, it's got a 1 in it. Do I already have a 1 written down? Technically I don't have to have a 1, but I'm going to go ahead and put it. And I put it at the front because it's by itself. It doesn't have a plus or minus sign, so there's nothing to put in parentheses. So I like to put my single terms first. So that's how I got my least common denominator here, okay? So it's just 1 times the x plus 2. Then what I can do to fix my numerators is my numerator was an x, so I'll keep it as an x. And it was over x plus 2. Well, what did I multiply that x plus 2 by on bottom? Just that 1. So I'll multiply the top by that 1. My second fraction was just a 2 in that numerator right there. And it was over 1. What did I multiply the 1 by in the denominator? Well, the x plus 2, so multiply this by, then top by x plus 2 as well. Now what I like to do then is I combine my numerators over my common denominator. So the first thing I'm going to do, guys, is I'm just going to rewrite it, especially because there's a minus sign there in the middle. So I have a 1x minus, now I remember how I like all my single stuff at the front, so I notice on the second part that I have a 2 there at the end that's by itself. So I'm going to write it back up there at the front of that term times the x plus 2, and it's all over that least common denominator. And then I simplify what I can. So 1x is just x. And I'm going to distribute the negative 2. So minus 2x minus 4 all over. Now I don't really need that 1 times at the beginning, so I'm just going to put x plus 2. Then combine like terms. So I got negative x minus 4 over x plus 2. And so that's what I'm going to use to find those key points that I needed. So I'm going to go find the x-intercept. So remember, that's where the numerator is equal to 0. So negative x minus 4 equals 0. So x will be negative 4. And my vertical asymptote, which is where the denominator equals 0. So x plus 2 equals 0, which is x equals negative 2. My inequality has an equal to, so the x-intercepts is going to be a bracket, and vertical asymptote is always going to be parentheses. Alright, so let's do our table. Well, actually, I'm not going to do the table. I'm going to let you do your table to finish this one up, but I wanted to get you through to where you got the fraction together because it's been a while since we added or subtracted fractions, and so we might have forgot. So you need to finish this, or it is on the notes that are in the blackboard.